Let's learn what is inheritance. The most common paradigm for inheritance is what we call single inheritance, and later we will know about the multiple inheritance. Going back to the problem, we referred that there is something common and there is something unique, and we ended up duplicating the code and would like to solve this problem. And I refer to two things, inheritance and the word reuse. The word reusability is a very fundamental concept in software engineering and in object-oriented programming. The code reusability means your ability to reuse something that you already did. And this is great because it avoids you a lot of problems. Remember, if we have an existing code that is working well, it means that we're already done with writing it, testing it, and solving a lot of its bugs. And already a lot of resources has been used to get this done. So the point now is, how can we make reuse of what is existing? This is what we call code reusability. There are two approaches for reusability: inheritance and composition. In practice, it's a bit challenging really in large scale projects to utilize reusability. There are a lot of reasons for that. In future, you might read this link. Now, going back to the two possible reusability approaches in programming or in OOP paradigm. The first one is called inheritance and the second one called composition. We already should know at this moment what is composition, and we will stress about it more later. The composition is a has-a relationship. I can say a building has floors, a floor has apartments, a car has an engine, and a car has four wheels. As you see, the has-a semantic is very visible. Inheritance, on the other side, is a relationship. Manager is an employee. Student is a person. When you would like to implement the composition, you do it as simple as you put an object inside an object. For example, if a full name is just first name and second name, like you create a class for a full name and put inside it a class first name, string first name and string last name. Observe your full name is a class and your first name and second name are classes. If you have a class for a car and class for an engine and class for wheels, you can create class for car and create inside it an object from engine and create a list of four wheels. This is what we call composition. You just create object of objects of objects. And we already saw that, although we didn't stress a lot its name. Now, today's topic is about the inheritance itself. So let's see how to implement inheritance. Let's use a simple example here. A person. We know that the student is a person. So what is a person? For simplicity, we have a class here that has some name and some email and some function for checking the is valid email and some function to print the data. It's a very trivial class, nothing here realistic. Now let's see the inheritance. The word inheritance, or when I say class A inherits class B, it means that it takes and inherits its attributes and properties and methods. In this case, we call the class A the parent class. Let's say an example here. I am creating a class student, but there is something new in the syntax. Instead of putting colon directly, we open these two parentheses and put the class name here, person. Now what does this mean? It means that the class student inherits the properties and the attributes and the methods of the person class. It is part of him. They can use it, they can see it. Now, we now define our init and property and print information in a very simple way. Observe here. The class person has name and email. The class student has GPA. However, it also has the name and the email, and also see the is valid email and print information. And this is all go back to the person keyword here, which help us to add all of these attributes to us. So again, the way that we solve the duplication problem through inheritance. To mark something to be inheriting from another thing, we use this parenthesis and put the class name. This syntax means now we see these attributes and these methods and we can use them. We see them. If you read here the print information, it say print self.name and self.gpa. Wait, we don't have a name here. Where is this attribute? This attribute is coming from my parent. We call the person class parent class, and we call the student class child class, or we call the person class base class, and we call the child class derived class. There is one more thing here which is critical about the initialization. If someone is trying to create an object from a student, is just creating a student and passing some attributes for it. Now how come the student class is going to initialize this guy? By default the init is going to be called, but what is going to call the init of the person class? By that I mean, let's say I'm calling here student st equal student. This is going by definition to call the init method here. But who is going to call the init method inside here? This is actually your responsibility. Let's go back to see the code. You see this line here, person.init self. You already saw in the quizzes some examples that help you to understand what does this mean. Person here is actually this class, and I'm forcing a call with the init method to the person class. So I'm forcing call here, and I'm passing myself to that guy. So now this function is going to be called and is going to add the name and the email for the object, and is going to return it back for me here. So as you see, the logic is as following. I have an init method and this guy has an init method, but when you create the object, only this init method will be seen. This is, by the way, we call it overriding. Remember when if you create a variable a equal 10, then variable a equal string Mustafa, we override the old value and see only the new value. So this is same logic here. The person class has an init method. The student class has an init method. Now this method overrides this method. So the student class only see the init method. And this guy would like to call the parent to initialize the name and the email here. And this guy here is making an explicit call to initialize these two things here. So that's all the moral of that. We now printing the info, which is printing the name and the email. We can print the email. We can call the isValid email. Observe here, I can create a person also, give it name and email, and print it, which is going to print again. Observe again for one more time. The print info method exists in the two classes, here and here. If you have an object from a student class and calling print info, only the parent class will be visible, not that one, because both of them exist. However, notice that the isValid email doesn't exist here. When this guy called isValid email, it goes to the student class. Does it have isValid email? No, it doesn't. So go to the parent. Does it have isValid email? Yes, it has it. So call the method. So the moral of that is, if the method here, we use it. If there are duplication, this old one is cancelled, overrode by this one. And here in the init method, you have to make an explicit call for the init method to initialize this guy here. I would like to stop here, and in the next video I'm going to continue explaining this part.